Example 1. Graph each quadratic by finding its vertex and intercepts. We can find the vertex of a quadratic by using the formula x is equal to negative b over 2 times a. This tells us what the x-coordinate of the axis of symmetry, or where the axis of symmetry is located. For our example here, a is equal to 1. It's the coefficient in front of the x squared term. B is equal to negative 2. There's no c term, there's no constant term. So x is going to be negative 2 over 2 times 1, or x is equal to 2 over 2. X is equal to 1. Then what we'll do to find the corresponding coordinate, the corresponding y-coordinate, let's find f of 1. We'll plug this back into the original function. And we get that f of 1 is 1 minus 2, or negative 1. So that means that our vertex is going to be located at 1, negative 1. The first number that we find is h, and the second number that we find is k. So this is our vertex. To find the x-intercepts, we're going to let y equals 0, or we're solving the equation 0 equals x squared minus 2x. We can factor this into x times x minus 2. So then either x is equal to 0 or x minus 2 is equal to 0. So we get x is 0 or x is 2. So our x-intercepts are going to be 0, 0, and 2, 0. And then for our y-intercept, we're going to let x equal 0. So we're going to find f of 0, which is 0 squared minus 2 times 0, which is 0. So our y-intercept is 0, 0. That matches up with the x-intercept that we found over there as well. So let's put this all together on the graph. Let's start with our vertex, which is going to be at 1, negative 1, which is here. I'm going to make this a little bigger. We've got a y-intercept and x-intercept here at the origin. And then we've got another intercept at 2 here. And so it looks like our parabola is going to be facing up like this. We also know it's facing up because our first value a is positive. All right, let's do another example. For our next example, we have the quadratic x squared minus 6x minus 1. For this example, a is equal to 1, b is equal to negative 6, and c is equal to negative 1. Let's start by finding the vertex. The h value is going to be where the axis of symmetry is. X equals negative b over 2 times a. Let's see, b is negative 6, and a is 1. So I'm getting 6 over 2, or 3. To find the corresponding value for the vertex, we will plug 3 into the original. So f of 3 is equal to 3 squared minus 6 times 3 minus 1, which is negative 10. So this first value ends up being our h of our vertex, and this ends up being k of our vertex. So we think that our vertex is going to be at 3, negative 10. Let's find our y-intercept first. So our y-intercept is going to be when we let x equal 0. So we'll have 0 squared minus 6 times 0 minus 1. So it looks like we're getting negative 1 as our y-intercept. And then for our x-intercept, we want to let y equal 0. And it turns out in this case that we have something that can't be factored, so we've got to use the quadratic formula. We already found a, b, and c over here. So we're going to find our x-intercepts by solving x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So negative 6, and then we'll have negative 6 squared, 1, negative 1, and then this whole thing is over 2 times 1. All right, so x is 6 plus or minus, let's see what's underneath that square root there. 36 plus 4 is going to be 40 over 2. This can be simplified to 2 times the square root of 10. And then this 2 can divide into both of these items here. So I think that we'll get x is 3 plus or minus the square root of 10. I want to write out the decimal approximations of this just because I want to be able to graph this. So I'm going to plug in 3 plus the square root of 10 into the calculator to get a decimal approximation. And I'm getting about 6.16. And then I'll plug in 3 minus the square root of 10. And we're getting approximately negative 0.16. I'm just doing that because I want to be able to graph this. So our x-intercepts here are 3 plus root 10 comma 0 and 3 minus root 10 comma 0. So these are our x-intercepts. And then our y-intercept was up here. All right, let's put this all together on our graph. So our vertex is at 3, negative 10. So that is way down here. Our y-intercept is at 0, negative 1. That's here. And then our x-intercepts were at 6.1, so maybe about here. And then negative 0.16, so maybe here-ish. And then we'll draw our parabola like this. Again, A is positive in this case, so that matches up with the parabola facing up. In this next example, our A term is negative, so we're expecting the parabola to be facing down. A is negative 1, B is 5, and C is negative 6. Let's start by finding our vertex. So we want to use x equals negative b over 2 times a. So that is negative 5 over 2 times negative 1, or x is equal to 5 halves. And then to find the corresponding value that goes with that, we're going to plug that value back into the function. So we want to find f of 5 halves, which is negative 5 halves squared plus 5 times 5 over 2 minus 6. Notice that the negative sign is on the outside. The only thing being squared is the 5 halves, not the negative sign. So this is going to be 25 over 4, and there's still a negative sign in front of it. I'm going to have then plus 25 over 2 and minus 6. Let's grab a calculator to simplify this. Let's see, negative 25 over 4 plus 25 over 2 minus 6, and I'm getting 1/4. So we think that our vertex is, this value is h and this value is k. So our vertex is going to be at 5/2, 1/4. Okay. And then let's find our y-intercept. Let x equal 0. So f of 0 is -0 squared plus 5 times 0 minus 6, or -6. So this is our y-intercept. And then for our x-intercept, let's see if we can factor this. We want to solve the equation 0 equals negative x squared plus 5x minus 6. It's helpful to factor the negative sign out into the front. And then I can see that this factors into x minus 2x minus 3. So I think that my x-intercepts are going to be either 2 or 3. All right, let's put this all together on the graph. We're expecting this graph to be pointing down because of the negative sign in front of the x squared term. So my vertex, 5/2 is about 2.5, and then 1/4, so 2.5, so it's right around here somewhere. My x-intercepts are, I'm going to make this bigger. This is really small graph here and here. And then my y-intercept was at, what was that? -6, so down here. So I think my graph is going to look like this. There's going to be another -6 equally. So this is 2 spaces over this. I'm going to go another 2 spaces over to make this symmetric. So it's probably going to be like this. There's a pretty good picture of our graph. And then for our last example, we have 4x squared minus 12x minus 3. In this example, a is equal to 4, b is equal to -12, c is equal to -3. The first coordinate of our vertex will be at x equals -b over 2 times a, which is -12 over 2 times 4. So 12 over 8 is the same as 3/2. And then we'll find the corresponding y-coordinate by plugging 3/2 into the original. Three halves squared is going to be 9 over 4. This is going to be 36 over 2, which is -18, and then -3. Here the 4's are going to cancel, and I'll have 9 minus 18 minus 3, which is -12. So I think my vertex is going to come from here. This is h, this is k. My vertex is at 3/2 -12. All right, let's find our y-intercept by letting x equal 0. We're getting -3. So 0, -3 is our y-intercept. For our x-intercept, let's see if we can factor this. It looks like this one's not factorable, so we're going to have to use the quadratic formula again. So we're trying to solve the equation 0 equals 4x squared minus 12x minus 3. Oops, we're not finding the y-intercept, we just did that. We're finding the x-intercepts by letting y equals 0. We have a is 4, b is negative 12, and c is negative 3. So let's use the quadratic formula. So negative 12, and then we'll have negative 12 squared minus 4 times 4 times negative 3, all underneath the square root. And this is divided by 2 times 4. Negative 12 is positive 12. 144 plus 16 times 3 is 48 over 8. So 12 plus or minus the square root of 192 over 8. I think that 192 can be simplified. That is 8 times the square root of 3. I'm going to split this up into two separate fractions. This is the same as 12 over 8 plus or minus 8 root 3 over 8, or 3 halves plus or minus the square root of 3. So these are our x-intercepts. I'll write it over here. 3 halves plus root 3 comma 0, and 3 halves minus root 3 comma 0. Let's put some decimal approximations as well to make it easier to graph. I'm going to move this over here. Let's see, 3 halves plus the square root of 3 is about 3.23. And then the 3 halves minus root 3, negative 0.23. All right, so we're going to put this all together. Let's start with our vertex. 3 halves and negative 12. This grid only goes down to negative 10 here, so I'll make a couple more lines. This would be, maybe 11 would be here, and 12 would be here. Just extending this down. 3 halves is at 1.5, so I think I'm going to be here-ish for my vertex. 3 halves, negative 12. My x-intercepts are at 3.23, so maybe here-ish, and negative 0.23, so oops, so over here. And then our y-intercept was at negative 3, so here. All right, my axis of symmetry is right here, and I want to have something on the equal side. This is going to be symmetric, so I'm going to go over here, and there's going to be another value that's symmetric to that y-intercept there. And then I will kind of just pretend that this looks like a smooth, continuous graph. Hard to make that nice and smooth with a stylus, but you get the idea. So this is the way that we can use the vertex and the intercepts to get a rough sketch of our graph.